Hello everyone, my name is Prateek. I have made a project named Threadpool OS Simulator with the help of my team members Vansh and Chiranjbi. Today I am presenting my project titled Threadpool Management System. This project is based on the concept of multithreading, which helps a computer perform multiple tasks more efficiently. In simple words, instead of creating a new thread again and again for every task, we keep a set of ready threads and reuse them. This improves speed, saves memory, and reduces system overhead. Before showing this project, let me explain the main concept. A thread is a smallest unit of execution inside a process. A process can have one or more threads, and each thread can perform a separate task. When many tasks come at the same time, creating a new thread for each task takes time and resources. That is why we use a thread pool. A thread pool is a group of pre-created worker threads that wait for task. When a task arrives, it is assigned to an available thread. If no thread is free, the task waits in a queue. This makes a task handling faster and more organized. Now let us understand why this is important. If a system creates too many threads, it can become slow. Each thread uses memory, and switching between threads also takes processing time. This is called context switching overhead. A thread pool reduces this problem because threads are reused. So instead of wasting time creating and destroying threads, the system directly assigns work to existing threads. This is especially useful in servers, application, and real-time system where many requests come together. This system mainly works with three parts. First is the task queue. This stores all incoming tasks in order. Second is the thread pool, which contains worker threads ready to execute tasks. Third is task as executor or scheduler, which assigns tasks to free threads. This structure follows a simple flow. Task comes in, task waits in a queue, thread takes task get executed. This is called task scheduling. Scheduling is important because it decides which task should run first and which thread should handle it. Now let us look at the interface of the system. At the top there are navigation options that helps the user move through the project. A clean interface is important because it improves usability. If the layout is simple and clear, the user can understand the system quickly. Good UI design also reduces confusion and makes the system easier to operate. When I hover over an option, it highlights, showing that it is interactive. This is a basic example of user feedback which helps the user know what can be clicked. Now I will show how a task is added. Here, the user enters task details. These details may include task name, execution time, or any other required value depending on the project design. After entering the details, the task is submitted. At this point, the task is not executed immediately. First, it enters the queue. This queue-based approach is important because it helps the system manage multiple requests in an orderly way. If many tasks come together, they are handled one by one by available threads. Now let us see how execution works. When the system starts, worker threads look for available tasks. If a task is present in the queue, one free thread picks it up. That thread then executes the task independently. This is the main advantage of multithreading. More than one task can be processed at the same time. If one task is slow, it does not stop the other task from running. This increases overall performance and responsiveness. In a good thread pool system, the threads keep working until all tasks are completed. One of the most important features of this system is thread reuse. When a thread finishes one task, it does not get destroyed immediately. Instead, it goes back into the pool and waits for another task. This saves the time and resources. It also reduces the burden on the CPU and memory. This is why thread pools are reused in systems where many short tasks are processed repeatedly. So thread reuse is one of the main reasons thread pools are efficient. This concept is used in many real-world applications. For example, web servers use thread pools to handle multiple user requests. If a new thread is created for every request, the system can slow down. With a thread pool, the server uses existing thread and responds faster. Now let us discuss the advantage. First, it improves performance. Second, it reduces thread creation overhead. Third, it saves memory because threads are reused. Fourth, it improves scalability, which means the system can handle more tasks efficiently. In short, the system is faster, cleaner, and more efficient than creating threads separately for every task. This project helps us understand how modern systems manage workload efficiently. In future, it can be improved by adding priority-based scheduling, dynamic thread allocation, and better monitoring features. Thank you.